Hello. So I'm talking about resistors in parallel. So what will happen to equivalent resistance when resistors are connected in parallel? So in this figure, you can see three resistors connected in parallel: R1, R2, and R3, right? Because these are in parallel, and the potential difference across three registers is same, so potential across all of these is V, but current will be different because you know the junction rule, Kirchhoff's junction rule. When current is passing through this circuit, what will happen is current will be divided. Let's say current passing through the first one will be I1, and current passing through the second one will be I2, and current passing through here will be I3. So this is the junction rule, right? The overall the current is I here. So from there the total current in this circuit will be I1 plus I2 plus I3, three currents. This is first equation. Now let's write down the expression for I1. What will be the I1 across this one? So potential will be same. So we know from the Ohm's law the voltage equal to R1 I1, because the potential is same, P here, P here, and B here, right? Same potential. So from there we can get like I1, because I need equation for I1 to insert in this equation. Let's say this is equation 1, and from here I1 will be B divided by R1. Similarly, we can write down B equal to R2 I2, because from this second resistance the current passing through is I2 and the resistance is R2. This implies that I2 is equal to B divided by R2. Similarly, for the third one, this one, we can write it down like B equal to I3 R3 I3, which is equivalent to I3 is equal to B divided by R3, right? Inserting all of these three values, let's say this is equation 2, right? Putting in this equation, we can get interesting relationship, which is I is equal to I1 is V divided by R1 plus B divided by R2 plus B divided by R3. But look at here, from, let me just little bit rearrange here. If I put I here and equal to sign over here, let me just rearrange it. This B is common for all of these three, that's why I'm eliminating this B from everyone and putting 1 1 1. So B is common here, right? So we can take common here. Dividing by B on the both sides, you'll cancel this one. So if we can cancel this value, why not we erase everything? I mean this B, and I'm erasing this as well, and I have now I divided by B. What is I divided by B? You know from Ohm's law, B equal to Ri. If there is something like I divided by B, this will be 1 by R, right? So from there I can write it down like left hand side is 1 divided by R equivalent, because this is the equivalent resistance, which is because of the sum of all of these resistances connected in parallel, right? R1, R2, and R3 overall. So this is the equivalent resistance. The reciprocal of the equivalent resistance will be equal to the sum of the reciprocals of the individual resistances, right? From there we understand that when resistors are connected in parallel, equivalent resistance will be decreased. On the other hand, if you connect these resistances in series, what will happen is overall resistance will increase, right? There will be direct summation of all of the individual resistances.